recording has started. Now let me share my screen. By now I think everyone should be able to see my screen. So I have my VS Code here. So we will be practicing along fundamentals of Python, and we'll be running it. And for that, we'll be doing that till the end of the class. I hope we're able to take it to a very good aspect before we stop. Yeah, let's take it to it. So first thing first, I know I showed us how to use Python, how to run Python from the interactive mode, which is the terminal, and then how to run it as a script. Now shows a way that is much more better for practicing and starting in the long run you'll be using scripting method. But then I want to show us how to use Jupyter Notebook. So we're using Jupyter Notebook because Jupyter Notebook provides us with kernels that we can easily run our code inside of Jupyter Notebook, and then um, we can easily run it inside of Jupyter Notebook and move on easily. So one thing I'll try to do here is I'll create a new file. I will say day2 dot. Now, if it's a Python file, I will say .py. But now I want to create a Jupyter Notebook. I will say .ipy. You can see there's py2 .ipynb. So that's a Jupyter Notebook. So I'm going to create the notebook. It's going to create it for me. Now, so that you can have Jupyter Notebook installed, you might not have it installed. You have to go to your extension here. Type Jupyter. Okay, and install this first one. Just install it. You can see I have installed it before, but you can just install it from scratch again. I hope that makes sense and you understand that. So that's how to install Jupyter. So with that, you're having Jupyter, Python, and Jupyter, Python, and what do we call it? Jupyter, Python, and VS Code run together. So this is it. You can just create a new code. It's trying to dictate kernel. I'll wait for it to try to dictate so we can select a kernel. So that kernel is what is going to detect. Let me click on select kernel. Let me click on select kernel. You can see try to find somewhere. So it's going to try to detect Python environment, and then based on that, when we click it, and then use Python environment, it's trying to find Python environments that I have on my PC. So I'll be going with this. You can say I have different Python environments. I have Python 3.10, 3.11, 3.14, 3. How to use Python 3.10? So I'm selecting that, and then I'll be using it. I hope we all understood that aspect. I hope we all understood that part. So instead of writing hello world, saving, running in terminal, you can easily come here. You can easily come here and say print. Now, print hello world. And when I click on Shift Enter, it will start trying to run it. And then to display the output for me below. It will display the output for me below. So let us see how that works. We're connecting to kernel Python 3.10, connecting using Python environments. It's taking a while to run that. Let us wait for it. Once it's done, it will not be it's taking so long. It's taking such a long time. It won't be done. See what's happening. I think I need to take this now. Here you can see now it has connected. It has run this way. So another way to run actually, another way to run, you click on this one. B. You can click on this play button. Click on the play button and use it to run. Use it to run. So it's not too difficult. I hope you understand that. Now let's come in into more with aspect of it. A minute, please. So now I'm going to discuss about variables. After discuss about variables, I will show you how to create variables and then how to run them. It looks much more easy to do. So first phase I will try to create different codes here, different cells here. Then also have different cells so that we can just continue using it to test and we don't have to create one by one. I've created quite a lot of them right now so that we can use it to practice. So we just move on. So our first aspect will be, I think there are some. Okay, this one. Let's come to Python. So now we want to write variable store value. So we want to create variables and use them to store values. Note we can have our values in what? In different types. We can have our values in different types. So let me paste this here. So now we have variables store value. We have name. We are saving name as what? As other. And to store that, we just have to do equals to this equals to 1. Because if you use 2, 3, they have different meaning. So using 1 is very, very much okay. And you say name equals other. That means name is other. Name equals 20 is name is 20. Height equals 1.68 means height is 1.68. Is student equals true means if person is a student, true. So now we have different data types. Other is a what? Is a string. Why? It is encapsulated in these two in these two quotes. So a string is encapsulated in those two quotes, and then they have context inside of them. Age here is what? Is an integer. We call it integer. So integer means it has number in it, a whole number. Integer means a whole number. You can see height is 1.68. It is not an integer. It is a what? It is a float because it does what? It does as decimal points. It has decimal points. So name equals Ada, age equals 20, which is an integer, height equals 1.68, his student equals true. Now we can say if you put age is this now. Now this age now is a string. Because of what? We have encapsulated it into using this what do we call it? This quotes. So it is wrong to have that. It is wrong to have that. That is how we have our string here. You understand? So let us print this. Let us print this. So you see, we are going to have name is Ada, age is 20, height is 1.68, his student is what? True. The student is true. Now I want to check. We want to check the data types for each and all of them. We want to take data type for each of them. You don't want to be like, you don't want to guess. We want to say, okay, what's actually inside? It is actually what? What's actually inside? Now to check what is actually inside, I'll paste this code up. I don't start writing here, so I will take our time. So we say print type name. Type name, we say, okay, what's the type? What's the type of data inside this name? Type age, we say, what's the type of data inside this age? What's the type of data inside height and then the student? Now print will now do what? Print will now print them out. To print So that's how we have our type. Print type name, print type age, print type height, print type students. So now let's try to run it and see the output that it does give us. So you can see class string. This is a string. This is what? Class int, integer. Class float. This is a float. Class boolean. So you say bool, that's boolean. So boolean are just true and false. Boolean is true and false. Do you understand? Do you understand? That's what boolean is about. So right now let us move on to the next concept, which is yes, before we move on to that, none represents no value yet. It is useful. Let us use none. We have none also. What none does is it lets us know when something is present or when it's not present. None represents no value yet. It is useful when a value will be assigned later. So if you don't have a value yet, but you will assign a value to it later, say no value yet. I say middle name, we're saying middle name now equals none. There's nothing for it available. Print middle name, print type middle name. Don't see middle name equals none. Type, the class is non-type. The class is non-type. Do you understand? That is what this is all about presently. Now let's move on to. If you have any questions, please do let me know. Let's move on to naming convention of different variables. Naming convention of different variables. So we have variable naming convention. Use lowercase words separated by underscore. In our last slide, we discussed about casing or styling. Yeah, variable styling. We have camel case, we have Pascal case, we have snake case. So let me give a sample of this is a camel, no, this is a camel case. This is a camel case, camel, camel case, this Pascal case, Pascal case, this is snake case, snake case. You understand? That's how we write it. So you can start with a lower word using separated underscore. That's for snake case. Use clear names that explain the data. Use clear names that explain data. Boolean variable often starts with is, has, or can. That's for Boolean variable. Now, we don't start a variable name with a number or an with a number or special characters. We can accept underscore. We can start with underscore, but you can't start with a number or special characters. You can have numbers in between or at the end of your naming of a variable name, but you can't have special characters unless underscore between your name. So example is we can't do this. We can have one name, one name. This is wrong. This is wrong. We can't have percentage name. This is wrong. We can have name one, which is right. We can't have name percentage, it is wrong. We can have underscore name, which is right. You can have name underscore, which is right. Do you understand? So those are the things that we should always look out for. So now we're saying student score equals 85 as paid fees equals false. Is illegible equals score greater than 50. Now that's a condition. Is score greater than 50? It will check it and let us know. It will check it and let us know. So now we are saying student score is what? 85. As the person paid fee, false, the person has not paid. Is illegible. Is the person illegible? Student score greater than 50. If it is score greater than 50, yes, it's 5 actually greater than 50. So let's print if it is illegible. You can see eligible equals what? Equals true. So that's how you can see variables and then do some stuff regarding it. Okay, so let's continue. So casting means converting from one data type to another. Converting from one data type to another. We can cast from one data type to actually other different data types. We can cast from number to from string to int on some scenarios. Some scenarios they are not possible. We can cast from int to float. We can cast from float to int, and we can cast from int to string and from float to string. Very much possible. Some will always be possible, some will not be possible. Let me give us examples. So we say int equals 1 equals 5, float equals 7.0, no, that's float. We say string equals, I'll put int 1, float 1, because those are keywords. These are keywords, so I don't use keywords. Change equals to Ade. Okay, sorry about that. My network went bad. I'm back now. A minute, let me see my screen. Okay, I hope you can see my screen back now. So we are trying to discuss about um casting of data type. That means converting one data type to the other. So we are doing, I'll say string 2 now. We have 5. So now we have this as int, which is 5. This is as float 7.0. String, this is string and contains array. This is string and contains 75. Now this string here, we can convert it to int or float. You can say int string 2. I've not run this. Just give me an error. Because I've not run this. That before running this. Just give me an error right now. Let me run this. So okay, let me come back and run this now. You can see int string, it has turned it to 75. Switch, if I say string 2 alone, if I say string 2 alone, it will give, you see that 2 quotations on it. You can see, you are seeing the quotations on it. But then int, it has turned it to an integer. If I say float now, float, and I run it, it's turning to float. You see 0.05 at the back, 0.0 at the back. Do you understand? You can change this to. But now, let's try to see for string 1. String 1, we can't change this one to integer or float. Why? It contains alphabet in it. It contains alphabet in it. If I say try to run this now, it's going to give me an error. It's going to say could not convert string to float. Why it can convert this to float? Now converting. Now for the int now. For the int, I can say string. I want to convert int 1 to string. Int 1. It's going to convert it to string. What anything can be converted to string. It will just add it will just add the quotation to the front and the back. You understand? It will add the quotation to the front and to the back. Do you understand? So that's it. If I say float 2 here now, if I say float 1 now, seven point zero, it will add the quotation to the back. We can change that. So we can also say int this float. Int, I want to change that float, I want to change it to int. So you're just going to change it. It's going to change it from 7.0 to what? To 7 directly. And if I say float int 1, float int 1, it will give me 5.0. It's changing it from 5 to 5.0. I hope you all understand that. So that's that about that. Now let us move on to the arithmetic operators. Arithmetic operators are quite easy peasy, not too stressful. We have arithmetic operators. Let's see this here. They are simple. So arithmetic operators, we have A as 10. A is 10, B is 3. Addition, A plus B, plus 3. Normal addition, subtraction, multiplication, division. We now have floor division and remainder. That's the 2 things that I want us to take note. So floor division will give us the output without any remainder. Remainder will give us only the remainder. So let's run it now. 13 plus 7 plus 30. Division has given us 33.3333. But now for floor division, it's going to give us what? 3 only, leaving the remainder out of it. Remainder will give us the remainder only. 3 remainder 1, it will give us the remainder only. Now, power is saying 10 raised to power 3, 10 times 3 times 10 times 10 times 10. That's 1000, which is quite pretty much straightforward. Now, let's come to operator precedence. So now we have how different operators, how they preside over each other, just like we have board mass. Now, multiplication happens before addition. Imagine this case scenario without parentheses. Multiplication will happen. We say 3 times 4, 12 plus 2, 14. And if you use this one, I'm going to say 2 plus 3, that is 5, times 4, that's 20. Which could be a very difficult hassle when we are doing some calculations that require some financial stuff, and then we are. So this is very useful. We have to know the precedence of operators. Moving on from there, you want to move on to comparison operators. So you can actually use compare. That's where we see greater than, less than, equals to, greater than or equals to, not equals to. So say A greater than B. Is 10 greater than 3? Yes. Let's add more. 10 greater than 3. Is A equals B? Is A equals to B? That means is A B? I don't know if you get me. Equals mean are they the same? Now the next one is exclamation mark equals, not equals. A not equals B. A not equals B. The next one is A greater than or equals to B. A less than B. You also have less than or equals to 2. So now let us run it. You see A greater than B, 10 greater than B, sure. 10 equals to 3. No, 10 is not equals to 3, that's false. 10 not equals to 3, true. 10 greater than or equals to 3. Yes, greater than 3, true. 10 less than 3, false. That's why we have false. So those are our comparison operators. They return Boolean. Either true or false. They return Boolean either true or they return false. I hope we are getting that. Welcome back, Mr. Synctellect Gramercy. I think you missed quite a lot. Perhaps this network. Are you with me? Please, can you say something? Can you make us say something?
I'm with you. I can hear you.
Okay. Do you understand? Okay, I'll just move on. So yeah, we have assignment operators. What assignment operators does is they update values. So let's say you say assignment operators update values. Wallet equals to 1000. So let's say wallet plus equals 500. Let me explain how that works for you. Details for you. You can say, if you say A equals 10. You say A plus equals 2. That means we are saying A is now equals to what? A plus 2. So we are saying A is now equals to what? A plus 2. Which means A is now equals to what? 12. So now we have eradicated this A here. That's what this is doing for us. So let's do this. Let me print A. You can see it is now printing A as what? It's now printing A as 12 instead of 10 that I have initially. It has worked on it. So now we say wallet equals to 1000. Wallet plus equals 5. That is what? That means wallet plus 500. That means that's 500. 15. Wallet minus 200. Minus equals 200. Remove 200 from it. 15 minus 200, that's 13. Now print wallet. Let's see. That's why we have 1 3 inside of our wallet. Does that make sense? Does that make sense? I hope it does make sense. So yes, I think that's what we have for today. Any questions so far? Next class we're talking about logical operators, sequence, strange sequence, indexing, slicing, and list, moving on like that. So yeah, please, do we have any question?
Sorry, if I may ask, please. Can you
Okay.
please tell the difference? Can you please tell the difference between the assignment operators and the variables? What are the differences between them?
Okay, let me. Now, assignment operator. If you're saying variable now, I'm saying wallet. Wallet equals to. Let me not use wallet. Age. Let me use age equals to 30. This is a, this is a variable age, which is storing a value which is what 30. You understand? That's the variable age. Now, if you want to say, sorry, your mic is disturbing. You want to say assignment operators. We want to now what do we call it? We want to put the value in it. Now, next year now, you'll be what? The person will be what? 31. What I'm now saying, age equals 31. You now write it and stating it now. You can easily do something. It's just like your banking system. You now say age plus equals. That means add what? Add 1 to the age. You now will say, okay, age equals to what? 31.
So,
It's just like when you're using this your bank statement. Your wallet is what your wallet is 1,000. You top up 100 naira. Let's say top up. I'll say top up equals to 100. Now your new wallet will be what? Your new wallet will be wallet plus equals. You don't have to state it again. Plus equals top up. That's what will be your new wallet. Now print wallet now. Print wallet. What do you say what? 1 1. Same thing if your wallet is what is deducting. You understand?
okay.
Wallet. Where am I put sorry, I put wallet in there. Yeah. So that's the assignment operators and the variables.
And
You
the
understand?
variables. Okay. All right.
So we are taking a break here for today. Here today. Turn up is quite slow and then I don't want to go far and people are not coming this class. If you don't understand this, you understand it. But by the way, the recordings will it is recorded and the recordings will be sent to the group on our YouTube channel. So you can actually reach out to it too and then use it to practice. Does that make sense?
All right. Thank you very much.
You are so welcome. Have a nice day. I think everybody has gone to Owambe. Can prepare for your own Owambe now. Perhaps I prepare for mine.
All right. Thanks for every time, sir. Thank you very much.
You're welcome. Have a nice day.